Here are the examples that I want to work through with you. If you want to actually put them in your notes, this page, this blank page, is found on page 7. For some of you, it may not be blank because we actually use this page as an activity, so you just do it on a separate sheet of paper and that will be fine. But if this page is blank, here's a good place to put it just so you can check, kind of go back and try them again before the test. So we'll start with going from a name to a compound. There's a couple of things that I would encourage you to look for. Look for how the name ends. That will tell you whether you have a binary compound, which means only a single element for your nonmetal, or you have a non-binary compound, which means you have a polyatomic ion for your nonmetal. So that's what you're going to do to figure out what your nonmetal is. Look at the ending. And then you're going to look at the metal. If it is a transitional or post-transitional metal, use the Roman numeral to find the charge, because you always have to have charges. If it is a regular metal, use the periodic table for the charge. Let's walk through these individually. So I'm going to start with lithium. I'll just do the metal and then the nonmetal, and then I'll balance the charges. Notice that when you are forming a compound formula, you always have to put the charges in. Anytime I'm working with the name to a formula, I have to put the charges in. Lithium, Li, that's pretty straightforward, and it's a regular metal because it's in column 1 of the periodic table. And I'm going to go ahead then and put the charge in because it's from column 1 of the periodic table. So it's +1. Oxide. Ide means it's just oxygen. It's not oxygen with something else. Ide means that it's all alone. The exception to that is hydroxide, which means it's polyatomic ion. I hate that it does that to you. And then oxygen. I just go to the periodic table for my binary nonmetals. And that's going to be -2. I look at the charges, I can't walk away, so I drop and swap. So the 2 goes here, a 1 would go here, but I don't have to write my 1. Notice I did not write a negative in front of the 2. All right, let's talk about the next one. Copper 2. Okay, that's not a regular, and the way I know that is because it has a Roman numeral. So I just use the Roman numeral for my charge. It is not the subscript, it is the charge. Remember, you're going to say transitional Roman charges in your head. Transitional elements use Roman numerals based on the charges. So the 2 here becomes a 2 here. And nitrite, ITE, that's not ide. That means it's a polyatomic ion. If it doesn't end in ide, it's a polyatomic ion. And I'm going to change this. I want carbonate. Sorry, I looked ahead. Carbonate. Nitrite, according to my list, is NO2 with a -1 charge. And again, I put parentheses around my polyatomic ions. And I have a +2 here, a -1 on the outside here. It's not the same. I can't walk away. So I put a 2 here. I don't need to put the 1 there. 1 is assumed. Tin 4 phosphide. Let's look at the tin first. Because there's a Roman numeral, oh, I know that it's going to be a transitional or post-transitional. Tin happens to be post-transitional, and it's a +4 charge. And phosphide. Ide means it is not a polyatomic ion. That means I got this right off the periodic table. And it's phosphorus. Phosphorus becomes phosphide. From the periodic table, that is a negative, I almost wrote a +3, is a -3. It's not the same. I can't walk away, so I drop and swap. The 3 goes here, and the 4 goes here. Calcium, oh, there's no Roman numeral there. It's because it's a regular metal, and I just go to the periodic table for that. That's +2. And then sulfide ends in IDE. It's not from the list, it's from the table. So I give it a -2. Remember, it's from the list of polyatomic ions if it ends in ate or ite. With the one exception, hydroxide ends in ide. You just have to know that one. This does not end in ate or ite, it ends in ide. So it came from the periodic table. Sulfide is from sulfur. Okay, now I have a +2 and a -2. What do I do with a +2, -2? Walk away. I just walk away. I'm going to switch this one out too. I'm looking ahead. Can you tell I'm looking ahead? Let's make this barium and SO4. Okay. The last one up here then is iron 3. Okay, it must be a transitional or post-transitional because it has the Roman numeral. So I'm going to put Fe +3, carbon 8. 8, okay, 8 or ite, it's from the list. And the list says that carbonate is CO3. I put parentheses around those. And it has a -2 charge. Not the same, can't walk away, drop and swap. So this is going to be 2, and this is going to be 3. Pretty straightforward. Just kind of keep those things in mind and walk your way through it. You look at the metal, and if it's a regular metal, the charge comes from the periodic table. If it is a transitional, post-transitional metal, the charge is going to come from the name. Then the nonmetal. If it ends in ide, go to the table. If it ends in ate or ite, go to the list of polyatomic ions. But in all cases, you have to get the charges. That's why I'm saying where to go for this. You have to get the charges to write the name or write the formula from the name. All right, now we're going to go from the formula back to the name. So we're working backwards. And I'm going to look at my first metal. I'm going to look at the metal and I'm going to say, is it regular or transitional, post-transitional? If it's regular, I can ignore. I don't have to deal with the charge at all. I just ignore it. If it's transitional or post-transitional, then I have to find the charge. This is transitional, post-transitional, so I have to find the charge. I'm right here with this. I have to find the charge. Well, where do I go to get the charge? I can't go to the periodic table for the charge. They don't give it to me. So where do I go? I go to my nonmetal. I find the charge based on the nonmetal. And basically, it's what I said before. You can pull it up. You can do the reverse. Instead of diagonally pulling it down, now diagonally, you can pull it up. So I could put a +4 here. So I got that charge from my nonmetal. And this is a -3 here. So it becomes, if I do that again, Pb3 N2. That means that this was -3. I pulled it, no, not N2, N4, sorry. This was -3 and I pulled it up. This is +4. Okay, now the reason I need that, it's already balanced. I would not do anything to these subscripts. I told you I wanted it to be Pb3N4. That's the ratio that they came in. We're not changing the subscripts, but I need the charges for the name. I have to have that charge for the name. So this would be Pb is lead. So it would be lead 4 one capital letter, 2 capital letters, nitride. Nitride. And this is going to be exactly the same as up here where I go for that information. Now for this one, again, it's lead. It's transitional, post-transitional. I have to find the charge. Now, I have no subscripts here. That meant I walked away, which means that I could have a multiple set of combinations as possibilities. It could be +1 -1, could be +2 -2, could be +3 -3. I don't know which one it is until I look at the nonmetal. I look at the nonmetal. The nonmetal is a -2. The only way I could walk away is if this is also a +2. How do I know I walked away? Because there are no subscripts down here. I walked away because it was the same charge number, opposite signs, +1, -1, +2, -2. So now I know how to name that. It's going to be lead to, 2 capital letters, so it's going to end in "ide," oxide. Now let's try the next one. Ba is a regular metal. I don't have to worry about Roman numerals. Notice for this one, a regular metal equals no Roman numerals in the name. In fact, it would be wrong if you did that. Because if you put a Roman numeral in there, you are giving the information that there are other options for this element, and that is completely wrong. So you're giving wrong information when you put the Roman numeral in. So if it's a regular metal, no Roman numerals. So this would just be barium. I have 3 capital letters, so it's not going to end in "ide." I have to figure out what this is. I go to my polyatomic ion list. It also helps that I have parentheses around it, and it's sulfate, barium sulfate. Iron, okay, that is a transitional metal, so I have to figure out the charge based on the nonmetal. I have charges down here. I'm sorry, not charges. I have subscripts down here, so I can just bring those subscripts up. So iron is going to be, notice that I pulled it up in the arrow to find the charges, just like when I have the charges, I pull them down in the arrow to find the subscripts. It works either way. So this is iron 3. Okay, so I don't know why I put lines over the tops on some of them and not on others. I'm very inconsistent. It doesn't matter. It doesn't matter. It's just a style thing. It does not matter at all. I have 3 capital letters, so that means I have a polyatomic ion. So I go to my list, and it is nitrate. And then the last one, potassium is a regular element, and I know that because I find it in column 1. So I don't have to deal with charges for that because regular metals have no Roman numerals, so I don't do that. It is potassium, 2 capital letters, so it's going to end in "ide," phosphide. Okay, that is how you do these. And again, if you have any questions, give me a holler.